Welcome to your deep dive. Today we're diving into the world of language. You've given us a bunch of articles and excerpts that really get into the nitty-gritty of how language develops, how it evolves, and how it all works. And we're here to kind of sift through all of that and find those like really interesting nuggets, the stuff that makes you go, whoa, I didn't know that.
Yeah, it's amazing how much we take language for granted. I mean, we use it so easily every single day, but it's actually one of the most complex things our brains can do. And going through these sources really brings that complexity to the forefront.
Yeah, for sure. And one of the things that jumped out at me right away was this whole concept of language as a biological instinct.
Mhm.
Like it's something we're born with, not just something we learn. It's almost like, how intricate the human eye is.
I
It's
think
like that.
that's a great analogy. Actually, one of the authors you included, Steven Pinker, he makes that argument that language isn't just some cultural invention. It's like a core human capability.
Mm.
He even compares it to, how Darwin was fascinated by how these complex biological systems like the eye evolved. It's like that with language.
So does that mean we're all like born poets then? Just waiting to, blossom?
Haha, not necessarily. While we might have this like innate capacity for language, actually mastering it and using it creatively is another story. But the evidence for this instinct is pretty strong. I mean, think about how even young kids understand grammar in ways that go beyond what they're explicitly taught.
It's true. It's amazing how they can put words together and make sense even before they've learned to tie their shoes.
Exactly. And it's not just about individual languages. The whole idea of pigeons and creoles, those kind of languages that emerge when people who speak different languages need to communicate, the sources had some great examples.
Yeah, they did.
And the interesting thing is pigeons are often pretty basic. You can't express complex ideas with them. But when children grow up hearing a pigeon, they spontaneously turn it into a creole, which is like a full-blown language
Yeah.
with a complex grammar.
It's like they're taking these basic building blocks and constructing a whole, full skyscraper of language.
Exactly. And Derek Bickerton, who's a linguist, he suggests that this whole process gives us a glimpse into the innate grammatical machinery of the brain. Kids aren't just copying what they hear, they're actively shaping the language.
Yeah, the example of Nicaraguan Sign Language, or ISN, was fascinating. It just emerged organically among deaf children in Nicaragua without any outside influence.
It's a powerful example of how strong this language instinct can be. But it also makes you wonder what happens when that instinct is disrupted or delayed.
Which brings us to the case of Jeannie, the child who was isolated and didn't have any exposure to language until she was a teenager.
It's a really sad story, but it highlights how important early exposure to language is. Even with intensive therapy, she struggled to master language. It suggests that maybe there are critical periods for language development.
It's like our brains aren't just blank slates waiting to be written on. They're primed for language at certain times in our development. Which reminds me of the concept of senescence, how our ability to learn changes as we age.
Yeah, as we get older, our brains might become a little less flexible, less able to adapt to new info. And that could be one reason why learning a new language is often easier for kids than for adults.
Makes you think about all those studies trying to find grammar genes, whether there's a genetic basis for our language abilities.
There's definitely evidence that genetics plays a role, Myrna Gopnik. She did research on a family with inherited specific language impairment, or SLI, and it points to the possibility that specific genes might influence our grammatical abilities.
And then there's all that research looking at brain structures of people with SLI, trying to see if there are any differences that might explain why they have trouble with language.
It's cutting-edge research, and it could give us some crucial insights into how our genes shape our ability for language.
Okay, so let's take a giant leap back in time now. Let's talk about the origins of language. Where did it all begin? It's kind of mysterious, isn't it?
Yeah.
How did we go from, basic grunts and gestures to all the languages we have today?
It's a question that has puzzled scientists and philosophers forever. We know for sure there's no easy answer. And some of those older theories, like the idea that language evolved from imitating animal sounds, they seem way too simplistic.
Right. Like the Bow Wow theory doesn't really explain how complex human language is.
Definitely not. One idea that's really interesting is that language might have evolved as a sort of arms race in social competition. As our ancestors started living in bigger, more complex groups, the ability to communicate well became a big advantage.
So being able to persuade, argue, share information, that would help them survive and thrive.
Exactly. Language would have allowed for more cooperation, better coordination, and ultimately more success in a world that was full of competition.
I wonder if those alarm calls that vervet monkeys use, as a basic form of communication, could that have been a sort of early step towards human language.
It's possible. Those long calls show that they have a basic understanding of using sounds to mean specific things. And that could have been a stepping stone towards more complex language systems.
Okay, time for a little myth busting. Let's talk about some of those common myths and misconceptions about language.
I'm all for it. Which one do you want to tackle first?
How about the classic Great Eskimo vocabulary hoax? The idea that Eskimos have like hundreds of words for snow? It's a perfect example of how cultural biases can kind of warp how we think about language.
Jeffrey Pullum, he wrote a whole paper debunking this myth. Turns out Eskimo languages have roughly the same number of words for snow as English does. It's more about how we categorize and see the world around us than about having a huge lexicon.
So it's not about having a separate word for every single type of snowflake. It's about how those words reflect a culture's relationship with its environment.
Exactly. And while we're at it, let's talk about that whole idea that English is going downhill because of things like slang or changing grammar rules.
Oh yeah, that whole kids these days are ruining the language argument. But language is always changing, and slang is a natural part of that. It's not decline, it's vitality, it's creativity.
Absolutely. New words and expressions pop up all the time. They make our language richer and they reflect how society is changing. It's not about being proper. It's about how language is actually used and how it adapts to new ways of communicating.
Like the whole debate about the singular they. Some people say it's wrong grammatically,
Right.
but it's been used for centuries. The sources you gave us showed how these rules often don't match how people actually speak.
That's a great point. Language is fluid, it's dynamic, and these prescriptive rules are often just trying to force order onto a system that's inherently flexible. Remember that guy William Safire who thought the word evolved came from involved?
Oh yeah. He thought language change was all about rhyming, when it's actually a much more complex process happening in our brains.
These examples just show us that language works on a much deeper level than we often realize. It's not just about words on a page or sounds in the air. There's a whole underlying structure and a bunch of unconscious rules that control how those elements come together to create meaning.
So it's like we've been talking about words and sentences this whole time. But there's this hidden architecture behind how they all work together.
Precisely. We could dive into things like phrase structure, which is how words group together to make meaningful phrases, or X-bar theory, which is a more abstract way of representing those relationships.
X-bar theory. Sounds pretty intense.
Don't worry, we'll keep it simple. We can use easy examples to show how grammatical rules work, and let's not forget about those mental dictionaries we all have, the huge stores of word meanings that our brains can access without even breaking a sweat.
It's mind-blowing when you think about how much information is packed into our brains just so we can talk to each other.
And that brings us to speech perception and production, the real stars of the show when it comes to language.
Feels like we've already covered a ton. And we've mostly focused on spoken language. Where does written language fit into all of this? That's a question for part 2.
Welcome back to our deep dive into language.
So before we jump into written language, we're talking about the actual mechanics of speech. You know how we take thoughts and turn them into sounds that carry meaning? It makes me wonder, how are those sounds actually produced? Like, what's going on in our bodies?
It's like we've got this super intricate wind instrument inside of us, and it's amazingly adaptable. That's basically what our vocal tract is.
Right. So we've got the lungs, the vocal cords, the tongue, teeth, lips, all these parts working together.
That's a great way to think about it. And how those parts coordinate is what determines the specific sounds we make. So first, air from our lungs gets pushed up through the trachea.
So the air is kind of like the fuel for speech.
Exactly. Then it passes through the larynx, which is where the vocal cords are, those two little folds of tissue.
Ah, the vocal cords. They're what give our voice its pitch and tone, right?
Right. When we speak, the vocal cords vibrate at different speeds or frequencies to create those changes in pitch. And men usually have thicker vocal cords than women, which is why their voices tend to be lower.
That makes sense. So then this vibrating air goes up through the pharynx, which is at the back of the throat, and into the oral cavity, our mouth.
And this is where things get really interesting. The tongue, the teeth, and the lips, they all work together to shape the sound waves, creating those distinct sounds of vowels and consonants.
Like how we round our lips for an ooh sound, or press our tongue to our teeth for a T.
Precisely. It's all about coordination and control. Each sound needs a specific set of movements, and we do this without even thinking about it most of the time.
It's pretty mind-blowing when you think about it. We're producing and understanding thousands of words every single day, and each one of those words is made up of this complex sequence of sounds orchestrated by these tiny movements in our vocal tract.
It really shows you how powerful and efficient the human brain is. We can communicate with so much precision and nuance.
Okay, so we've got the air flowing the vocal cords, vibrating the tongue and lips doing their thing.
Oh,
But how do those movements actually create the specific sounds that we hear as vowels and consonants?
it all comes down to how those movements shape the sound waves as they're traveling through the air. So let's start with vowels. When we say a vowel, the air flows pretty freely, but the shape of our mouth changes, and that creates different resonances.
Resonances, like echoes bouncing around in our mouth.
Exactly. And
Yeah.
those resonances determine the specific sound of each vowel. So for instance, when you say E, like in C, your tongue is high and forward in your mouth, and that creates a smaller resonant space.
And for ah, like in father, the tongue is lower and flatter, which makes a bigger resonant space.
Got it. Now, consonants are a bit more complicated. They involve some kind of blockage or narrowing of the airflow, and that creates different kinds of sounds.
Like when you say P, you close your lips completely and stop the air for a second.
Exactly. That's what we call a stop consonant because the airflow is completely stopped. Then you've got consonants like F or S, where you partially block the airflow, which creates that friction or turbulence.
Right, those are called fricatives because of that friction.
You got it. And then there are consonants like M or N, where the air goes through your nose, creating those nasal sounds.
So it's all about how the air is moving through the vocal tract, whether it's being stopped, constricted, or redirected.
That's the key. And those little differences in airflow combined with the vibrations of the vocal cords, that's what creates the incredible diversity of sounds that we use in human language.
It's like a symphony happening in our mouths. All this airflow and articulation.
And to really appreciate how complex this process is, think about the challenges that speech recognition engineers face. They've been trying to get computers to decode speech accurately for decades, and it's turned out to be a really tough problem.
It's true. It's not just about recognizing the individual sounds. It's about understanding how they're all strung together into words and sentences and ultimately into meaningful conversations.
And let's not forget about all the variations in accents and pronunciation, and even things like emotional tone. All things that our brains can handle with no problem.
It really shows you how much more sophisticated our brains are than even the most advanced AI systems.
It speaks to the amazing power of the human brain and how our biology and our experiences work together to shape our language abilities. So we've talked about how we produce speech, but what about the flip side? How do we actually perceive and understand those sound waves when they hit our ears?
That's what I'm really curious about. It seems like magic that we can take all those sounds and turn them into meaning.
It's a remarkable process, for sure. It all starts with those sound waves traveling down the ear canal and hitting the eardrum, making it vibrate.
Okay, so far so good. Basic anatomy.
But here's where things get really interesting. Those vibrations then get passed through those tiny bones in the middle ear to the cochlea, which is that spiral-shaped organ in the inner ear.
Oh yeah, the cochlea. I remember that from biology. It's full of fluid and has all those tiny hair cells.
Those hair cells are the key to hearing.
Right.
When the fluid in the cochlea vibrates, it bends those hair cells, and that triggers nerve impulses that travel to the brain through the auditory nerve.
So those hair cells are basically translating those mechanical vibrations into electrical signals that the brain can understand.
Exactly. And the brain is incredibly good at processing those signals. It can tell the difference between different frequencies, intensities, and durations of sounds. That's how we can perceive all the nuances of speech.
So that's how we know the difference between a high-pitched E and a low-pitched oo, or a loud shout and a quiet whisper.
Precisely. But the brain doesn't stop there. It also looks for patterns in the sounds, grouping them into syllables, words, and phrases.
It's amazing that all of this is happening in just milliseconds without us even realizing it.
And remember, this is all happening while we're surrounded by other sounds, traffic music, other people talking. The brain has to filter all that out and focus on the speech signals that matter.
Which it does a pretty good job of most of the time.
Right. And it's not just about recognizing sounds on their own. The brain also uses context, our knowledge of language and the world, to help us figure out what we're hearing.
So if we hear a word that could have multiple meanings, our brain uses the other words around it and the situation to figure out what it means.
Exactly. It's a dynamic process. It's a combination of bottom-up processing, where we analyze the acoustic signals themselves, and top-down processing, where our knowledge and expectations help guide our understanding.
So it's like our brains are always making predictions about what we're going to hear next based on what we've already heard and what we know about language in the world.
You got it. And that ability to predict is what allows us to understand speech so quickly and efficiently. It's also why speech perception can be so robust even in noisy or unclear environments. The brain can fill in gaps or correct mistakes based on what it expects to hear.
That's why we can understand someone, even if they're mumbling or have an accent or there's a lot of noise around.
Exactly. Our brains are really good at figuring out what words mean, even when the signal isn't perfect. Now we've talked about how we make speech and how we perceive it. It's amazing how those two processes work together to let us talk and listen.
I feel like I have a way better understanding of how we create and hear these sounds. It really is kind of magical.
Yeah.
Now I'm ready to tackle written language.
Let's dive into that fascinating world. Written language might be a relatively new invention in human history, but it's had a massive impact on how we communicate and think.
It's true. I can't imagine life without books or letters or even text messages.
But here's the thing. Written language isn't really all that different from spoken language. It's just another way of representing those same underlying linguistic structures that we've been discussing.
So those written symbols, the letters we see on a page, are basically stand-ins for the sounds we make when we speak.
Exactly. When we read, our brains are basically taking those visual symbols and converting them back into sounds, even if we don't actually say the words out loud.
It's like silent speech happening in our heads.
Kinda. And that process of converting visual symbols into sounds can be tricky, especially with English spelling and all its quirks.
Oh, don't even get me started on English spelling. It can be a real pain sometimes.
True, but it also reflects the history and evolution of the language. A lot of those weird spellings are leftovers from how words used to be pronounced or they were borrowed from other languages.
So those spellings are like little fossils, giving us clues about the past.
You could say that. But even with all its irregularities, English spelling is still mostly based on the alphabetic principle. The idea that written symbols represent the sounds of speech.
Which is pretty amazing when you think about it.
Mm-hmm.
We can represent a zillion words with just a small set of symbols.
That's the beauty of it. It's what makes reading and writing accessible to so many people. Of course, learning to read and write can be tough, especially for young kids.
I remember struggling with phonics and trying to sound out words when I was learning to read.
It takes time and practice for the brain to make those connections between written symbols and sounds. But once those connections are made, reading becomes a super efficient way to take in information and ideas.
And writing gives us a way to express our thoughts and be creative.
It's a powerful tool for communication and self-expression. We could spend hours talking about written language, from grammar and punctuation to different writing styles. But the main thing to remember is that it's a way to convey meaning just like spoken language.
So whether it's spoken words or written words, it's all about communication.
You got it. And that brings us back to the core idea of our deep dive. Language is incredibly dynamic. It's always evolving.
It's always changing, adapting to new situations. New words pop up, old words get new meanings, grammar rules shift.
It's a process that's been going on as long as humans have been communicating, and it shows how creative and adaptable our minds are.
It reminds us that language isn't fixed or rigid. There's no one right way to speak or write. What matters most is communicating, effectively sharing our ideas and connecting with each other through the power of language.
Couldn't have said it better myself. Language is truly a gift. It's what makes us human. We've explored its biological roots, how we speak and listen, debunked some common myths, and even touched on the evolution of written language.
And this is just the tip of the iceberg. There's so much more to learn about this amazing ability that makes us human. But before we wrap things up, there's one more crucial aspect of language that we need to talk about: how language develops in children. It's an amazing process that sheds light on how our genes and our environment interact to shape our linguistic skills. Let's explore that in part 3. Welcome back to our deep dive into language. We've gone from the biological basis of language to the mechanics of speech, and even touched on the evolution of writing. But now let's turn our attention to how language develops in those little language learning machines we call children.
It really is amazing when you think about it. You have a baby who starts with basically no knowledge of the world, and they gradually turn into this chattering, storytelling, question-asking child. It's a testament to the power of human development.
It's true. It almost seems like magic. How do they go from gurgling and babbling to mastering this complex system of communication? What are the key milestones along the way?
Well, even before they say their first word, babies are already absorbing language. They're tuning in to the sounds of their native language, recognizing patterns, and even starting to distinguish individual words.
So those coos and babbles, they actually serve a purpose. They're like little linguists in training.
Exactly. And usually around their first birthday, most babies start to produce their first words, often simple labels for familiar objects or people, like mama or dada. It's a huge milestone. It marks the beginning of their journey into the world of words.
I can imagine that's a pretty special moment for parents. It's like a whole new level of connection.
Absolutely. And from there, things start to take off. Children's vocabularies grow rapidly. They pick up new words at an incredible pace. By the time they're 2 years old, many kids have a vocabulary of a couple hundred words, and they're beginning to put those words together into simple two-word phrases.
Like want cookie or more milk. It's like their own little telegraphic language.
Precisely. And it's not just about vocabulary. They're also starting to understand the grammar of their language. They start to use plurals, verb tenses, and even figure out word order.
So even though they can't explain the rules, they're already using them intuitively. Pretty impressive when you think about it.
It really is. And as children continue to develop, their language skills just become more and more refined and complex. They start to produce longer sentences, tell stories, and have deeper conversations.
It's like they're unlocking new levels of expression with each passing year. It makes you wonder about the role of the environment in all of this. Are we born with a blueprint for language, or is it shaped by our experiences?
That's the classic nature versus nurture debate. And when it comes to language, it seems like both are crucial. We've already talked about the evidence for a biological predisposition for language, but it's clear that interaction and exposure to language are essential for children to fully develop their linguistic abilities.
So it's like we have the potential for language in our brains, but we need the right input from the environment to activate it and nurture it.
That's a great way to think about it. Think about it this way. Children who grow up surrounded by language, where they hear lots of conversations, stories, songs, they tend to develop language skills faster than children who have less exposure.
It makes perfect sense. It highlights how important it is for parents and caregivers to talk to their children, read to them, sing to them right from the start.
Exactly. Those early interactions are like the foundation for language development. They help children build their vocabulary, learn grammar, and develop those essential social and pragmatic aspects of communication.
But it's not just about the quantity of language, it's also about the quality, right? Just having the TV on in the background isn't going to be as effective as having a real back and forth conversation with a child.
You're absolutely right. It's those responsive interactions that are so valuable. When adults pay attention to what children are trying to communicate and respond in a meaningful way.
So it's about creating those opportunities for genuine communication, where children feel heard and understood. It makes me think about how we as adults can keep nurturing and supporting language development, even beyond those early years.
That's an important point to remember. Language learning doesn't stop when we graduate from school. We can keep expanding our vocabulary, improving our grammar, and even learning new languages throughout our lives.
So even though we're not picking up language as quickly as we did when we were toddlers, our brains are still capable of growth and change.
Absolutely. And learning languages throughout your life has benefits that go way beyond just being able to order food in a foreign country. It can actually improve your cognitive function, boost your memory, and even make you more creative.
Wow. It seems like the wonders of language never end. From its biological underpinnings to its effects on our brains and our social interactions.
It's been a real pleasure exploring all the different facets of language with you. We've delved into its origins, its structure, the way we produce and perceive it, and how it unfolds in children. And even after this deep dive, there's still so much more to uncover.
It's amazing to think about how complex this system is that we use so easily every day. Language truly is a remarkable gift. It allows us to connect with one another and express the full range of human thought and emotion. Thanks for joining us on this journey. We hope you've come away with a newfound appreciation for the power and beauty of language.